In this video, we want to learn the IUPAC nomenclature of alkane. Now, if you look at an alkane, it has a general formula of CN H2N plus 2. Now, this video is for those who have not named an organic compound before, and also for those who are professors or who are pro in naming organic compound also. Now, we want to start step by step, and then we'll go to most complex compound like that. Now, most of the exams will be covering carbon 1 to carbon 10 mostly, and some of the exam will cover from carbon 1 to carbon 20. I will have one on carbon 20. Maybe you want to know about that. That will be in a subsequent video also. Now, if I'm talking about carbon 1 should have how many hydrogen? Because these are hydrocarbons, carbon and hydrogen. Now, carbon 1, if it is 1, we're going to multiply the number of carbon by 2, because n is number of carbon. We'll multiply by 2n, which is 2 times 1, that will give me 2, then plus 2. That shows you that we're going to have 4 hydrogen atoms in it, in one carbon. For every one carbon, we have 4 hydrogens. Now, what if we have 2 carbons? If we have 2 carbons, we're going to be having 2 multiplied by 2. That's 4. 4 plus 2, that's going to give me 6. So for every 2 carbon, we have 6 hydrogen in it. Now, we're going to be talking about carbon 1. The carbon 1 is known as the methane. Let's write that here. The carbon 2 is known as the ethane. Then the carbon 3, if we have carbon 3, that is 3 times 2 for the number of hydrogen now. 3 times 2 is 6. 6 plus 2 is 8. Now we have carbon 3, we have hydrogen is 8. This is known as propane. All right, but what if it's carbon 4? Carbon 4, which is C4, H10, this is known as the butane. Then carbon 5, which is C5, H12, this is known as the pentane. Then the carbon 6, this is known as C6, H14, this is known as the hexane. Then the carbon 8, which is, carbon 7, which is C7, H16, is known as the heptane. Then carbon 8, which is C8, H18 now, is known as the octane. Now carbon 9, which is C9, H20, is known as the nonane. Now carbon 10, which is the C10, H22, is known as the decane. Now, we want to talk about the carbon 11. What is that called? That is called undecayed. Let's put that down. Carbon 11. This is undecayed. And then it's C11, H24. Now, H24. This is 22, just an increase in 2. When we talk about carbon 12, that is called dodecane. So we have carbon 12, dodecane. All right, which is C12, H26. When we talk about carbon 13, that is tridecane. You're going to do your math by yourself. Just finish it up now. Carbon 14, tetradecane, 15, pentadecane, 16, hexadecane, heptadecane for 17, octadecane for 18, and then nonadecane for 19, and then for 20 we have the icosahn. All right, now this is the list of 1 to 20 carbon atom under the family of alkane. Understand that the end name for all this compound is N. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane, tridecane, a lot of those. Now, the next thing to do is to look for the longest continuous chain of carbon atom. The longest continuous chain, let's say we have these 1, 2, 3, 4, 5. Okay? And let's say we have these 1, 2, 3, 4. We have this now. All right? And so we have this. We have this. We have this. Now, if you have these as a compound, what's the longest chain? Of course, the longest chain here is obviously this guy. All right? The longest continuous chain. But sometimes it's not usually always a straight chain. All right. Now look at this. 1, 2, 3, 4, 5. 5 is over here. 1, 2, 3, 4, 5, 6, 7. So which one do you think is the longest chain? 5 or 7? 7 is the longest chain from here. So we're going to be having these as the longest chain. So if that is done, we're going to fill in the hydrogen atom in it. Now, the hydrogen atom that we're going to be having here, if we fill in all the hydrogen atom like this, 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 1, 2, 3, 4, 5, 6. This is 6, and 6 is the Z. All right. Now, sometimes the organic compound can be represented in strokes. All right, something like this. Now, we're going to count the number of carbon from here. The edges, we have 1, 2, 3, 4, 5, 6, 7, 8. So this is octane. So this is what? Octane. All right. So let's name this guy over here. We're going to be putting the hydrogen atom in it. So let's put the hydrogen here. This should be H2. This should be CH3. This should be CH3. And then we have hydrogen here. And then we have hydrogen here. This should be CH2, 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 CH2. Now, we have a substituent in this compound. Over on the other side of the two compounds I gave to you over here, there is no substituent in it. Substituent is formed from, substituent is a family of alkyl, or alkyl, sorry. Substituent is a family of alkyl. That's a substituent. Remember that all these are alkane. So if substituent is a family of alkyl, I need to clean up the board now. But I'll leave 2, 3. Let's clean up everything. Now, how do we get an alkyl? An alkyl is originally an alkane and has lost an hydrogen atom. I take that again. An alkyl is originally an alkane that has lost an hydrogen atom. All right. Now let's say we have CH4. This is an alkane. Of course, it's called methane. If it loses an hydrogen atom, one hydrogen atom lost from it, it will form an alkyl. And this is CH3. And this becomes methyl. Now, it will change from methane to methyl. Understood? Now, if we have C2H6, which is an ethane, and then it loses an hydrogen atom, it will become C2H5. 6 minus 1 is 5. This will change from ethane to ethyl. All right, so if we have C3H8, and then this is a propane, and then it loses an hydrogen atom, it becomes C3H7. So C3H7, this will change from propane to propyl. Now, finally, now you can do for more and more and more of those. We have C4H10, this is a butane. And then, if the butane has lost one hydrogen, it becomes C4H9. This will change from butane to butyl. Now, having understood this, all these guys is called substituent. All this guy is called substituent. All this guy is called substituent. Now, these substituents could be attached to any of the longest chain carbon atom. These are all organic substituents. And we have some inorganic substituents also. The fluorine, the chlorine, the bromine, the iodine. That are the halogens in chemistry. They can act also as a substituent. Now let's look over here. We have a substituent here. This is a substituent. Now this is a substituent. All right, the substituent is CH3, which is a methyl. Now, the substituent on the other side of the diagram is C1. How many C do we have there? 2. How many hydrogen? 5. That's an ethyl. Now, the next thing to do is to look for the alphabetical arrangement. Now, E and M, which one should come first? E and M are E, A, B, C, D, then before we get to M. So E is the alphabetical arrangement. E comes before M. You're going to give E the lowest number. Let's take that again. You're going to give E, which is ethyl, the lowest number. So if we count from here, 1, 2, 3, 4, 5, 6, 7. So we have 4. Carbon atom 4 is carrying the ethyl. If you count from here, 1, 2, 3, 4, carbon atom 4 still carrying the ethyl. But you know, if you count from here, you're going to give an advantage to methyl, so that methyl we have 3. We need to give the substituent the lower number. That's what we're looking for. But when we count like this, 1, 2, 3, 4, ethyl, which comes before M, has 4. 1, 2, 3, 4. Ethyl, which comes before M, methyl, has 4. But over here, methyl will become 5, which we don't want that. So we want methyl also to enjoy some privilege. All right, so we'll take it 1, 2, 3, 4, 5, 6, 7. So we have 4 ethyl, 3 methyl, and then 7 is heptane. All right, so this is the name of this structure. Let's do another one. Let's say we have CH3, C2H5, CH2, CH3, okay, CH3. Okay, let me make it so that you understand what I'm saying. CH3. Let's make the CH3. Now, if you look at these, we have substituents. We have the substituent methyl, methyl. Okay, let me give you the stroke. All right. So if you have this, and you have this. All right. Now, let's take up the first one. The first one, we have a methyl. CH3 is a methyl. Methyl. And then we have a methyl. Now, over here, when we get to the stroke, I will explain that for you. Now, there's this methyl. We're going to give methyl the lowest number. You don't say 1, 2, 3, 4, 5, 4, 4 dimethyl pentane. That's wrong. What you do is that you're going to go to give the methyl the lowest number. So we have 1, 2, 3, 4, 5. So what we have here is 2, 2, 2, comma separate number, 2 dimethyl. How many is there? 1, 2, 3, 4, 5. Pentane. All right, so that's the answer to that compound, the name of that compound. And let's look at these. Now point out the edges. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 are the edges. That's there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a decade. That's the longest chain. And that's the parent's name, decade. But we have these carbon over here. We have this carbon over here. If it has 2 strokes, that's no more a methyl. This carbon here is a methyl. This carbon here is a methyl. But if you have something like this, let's name this first before we draw another diagram. So we have 1, 2, 3, 4. You get that? 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Oh, we're going to start from this side because we want to give the substituent the smallest number. So we have 1, 2, 3. This is 3. And over on the 4th carbon, third 1, 2, 3, 3rd carbon 2, 4th carbon. That's the 4th one. So we have 3, 4. 1, 2, 3. 3 for this methyl, 4 for this methyl. That's 3, 4. dimethyl, then 10 decane. All right, now the carbon atom carrying the substituent, the number of the carbon atom carrying the substituent should be named. Over here, 3 is carrying substituent 2, 3, 4 is carrying 4. How many methyl do we have? 2. That is dimethyl. If it's 3, trimethyl. If it's 4, tetramethyl, like that. Let's clean up the board. Let's say we have this CH3